Hello everyone. My name is Gauri. This is Group 7 from Division D, presenting you the working of Interrupt IO with the help of my fellow mates under the guidance of Lokesh Khedekar sir. What is interrupt driven IO? Interrupt driven IO is a technique used in a computer system to handle input output operations. It is a method of communication between CPU and peripherals, where the peripheral devices send signals to CPU to request service. In this technique, CPU doesn't continuously poll the peripherals for the data, but instead waits for an interrupt signal from the device. This approach allows the CPU to perform other tasks while waiting for the interrupt signal. So, what's I/O? I/O is a communication between a computer and external device like keyboard, monitor, and storage. Input refers to a data and commands received from external sources, while output refers to the result and responses sent back to those sources. I/O is a crucial for computer to interact with the users and external devices, allowing for input and output. Users can control the computer and provide information, while output gives feedback. I/O also enables communication with other devices and systems. There are basically two types of I/O. First one is traditional I/O and second one is interrupt driven I/O, which will be further explained by Atharva.
So we will be looking at traditional input-output. Traditional input-output refers to the basic input-output operations performed by a computer to communicate with peripherals. It involves transferring data through the system bus and is typically synchronous, meaning the CPU must wait for the operation to complete before proceeding. While simple and reliable, it may not be efficient for high performance computing, and modern systems often use more advanced input output methods. Next is how CPU handles input output requests. The CPU sends an IO request to the IO controller or device driver, which communicates with the peripheral device to perform the operation. After completing the operation, the IO controller sends an interrupt signal to the CPU, which retrieves and processes the data from an IO buffer. This cycle repeats until all required input output data is received. There are few drawbacks of traditional input-output, such as synchronous operation leading to performance issues, limited bandwidth, high CPU overhead, limited scalability, and inefficient use of system resources. Due to these drawbacks, we prefer interrupt-driven IOs. Interrupt-driven IO is a mechanism that efficiently handles input-output operations in computer systems. It allows the CPU to perform other tasks while waiting for I/O operations to complete and reduces response time. It is more efficient than traditional input-output, which involves CPU pooling and can be wasteful of system resources. Further, we'll see the working of I/O.
So now, what is working of interrupt-driven I/O? Interrupt-driven I/O allows the CPU to initiate an input-output operation and continue executing other instruction until an interrupt signal is received. An interrupt handler routine then performs the necessary processing before returning control to the CPU, improving system performance and efficiency.
So guys, here I am Mohit. I will explain you the interaction between the CPU and the I/O. The CPU initiates I/O operation by sending commands to the device controller. The device controller sends status update to the CPU during the operation. It means when the command that was read by the I/O, it will pass through the CPU through the address bus. Once the I/O operation is completed, the device controller sends an interrupt signal to the CPU. Then the CPU makes an interrupter that is jumps to the interrupt handle routine for processing before resume execution. This process enables efficient communication between CPU and the I/O devices. It means when the command read by the CPU, there is a interaction between the CPU and the I/O devices. So the interrupt driven I/O So next guys, I will explain you the flowchart of the interrupt driven IO processes. In this, IO module receives a read command from the processor. The IO module stores the data from the desired peripheral into data register. Then the IO module interrupt the processor. This IO module waits until the data is requested by the processor. It means when the data sent to the processor, firstly check the status what is the data will be. Then the CPU read this IO data that was sent through the address bus. Then it may work on it, and that is it may process on it. After that, the CPU made this data in, and that is it saves data into the memory, and then it give to the monitor to display. Then this process will be done. If a user want to make this repeated, then this process will be happen continuously.
So now we will see how the interrupts are handled. So interrupts are handled by the CPU through a specific routine called an interrupt handler. When an interrupt signal is received from the device, the CPU stops executing its current instruction and jumps to the memory location of the interrupt handler. The interrupt handler performs the necessary processing related to the interrupt and then returns the control to the CPU, which resumes execution from where it left off. This process allows the CPU to respond quickly to external events without having to constantly check for it. This improves the system performance and its efficiency.
So, what are the advantages of interrupt driven input output? Advantages of interrupt driven input output. So, first, improved system performance. Second, reduce processing overhead. Third, faster response time. Fourth, more efficient use of system resources. Fifth, simplified software design. So, interrupt driven input output allows the CPU to execute other instructions while waiting for input output operation to complete, reducing processing overhead, improving efficiency, and enabling faster response times to external events. The method can handle multiple tasks simultaneously, making more efficient use of system resources and simplifying software design.
The drawbacks of interrupt-driven input-output are increased complexity, limited number of interrupts, interrupt latency, interrupt priority conflicts, overhead from context switching.
So, thank you. That's it from our side on working of interrupt driven input output.